In the first part of Chapter 3, we are going to talk about probability terminology. So, what is a random event? An event is truly random if each outcome has an equal chance of occurring. For example, if you flip a coin, half the times it'll be heads, theoretically, and half the time it'll be tails. Both outcomes have an equal chance of occurring. If you roll a die, you can land on a 1, a 2, a 3, or a 4, or a 5, or a 6. But all these outcomes have an equal chance of occurring. So those are random events. Now, an informal definition of probability is the chance or likelihood that an event will occur. Okay, but what does that really mean? Like, let's say I tell you there's a 20% probability it's going to rain tomorrow. What does that mean other than, it's kind of a low probability? So we need a little bit of a formal definition. So a formal definition is as follows. Probability is the predicted. Now, predicted means this is what we think is going to happen theoretically, but most of the time, it won't be exactly as predicted. And then the other term is long run. So probability is only valid if you do something over and over and over and over and over and over and over again. So probability is a predicted long run relative frequency of an event. For example, let's say I flip a coin 10 times. It could very well happen that I get 7 heads and 3 tails. Or maybe I'll end up getting 2 heads and 8 tails. In such a short series of trials, in 10 trials, anything can happen, right? We're not guaranteed to get exactly 5 and 5. So probability, though, in the long run, if we flip a coin 1,000 times, then we will get approximately 500 heads and 500 tails, approximately. It might be 498 heads and 502 tails, or it might be 501 heads and 499 tails. Whatever it is, it'll be pretty close to half and half. Whereas if you just do it 10 times, despite luck or probability, it could be whether, something like this, where you get 7 heads and 3 tails, or 2 heads and 8 tails, where it's not exactly half and half. Now the terminology is P of W, so P stands for probability and W stands for whatever event. So P of W would mean the probability of winning. So probability is if you do something over and over and over again, many times over, then the probability of an event is the proportion of times we actually saw the event occurring. Now, the basics of probability is as follows. The probability of any event A is given by the number of outcomes in A divided by the total number of outcomes possible. So the numerator is the number of successes, however we define a success, and the number of denominator is the total number of possibilities. Okay, for example, let's say we roll a 6-sided die once. The sample space is a list of all the outcomes. We have 6 possible outcomes. It can land on a 1, a 2, a 3, or a 4, or a 5, or a 6. Those are all the possible outcomes. Now we want to find the probability of rolling a 1. So according to this definition, probability is the number of successes. So a success is anytime we roll a 1. So the question we ask ourselves is how many 1s are possible? Now here we have 6 possibilities, only one of them is a 1. So there is a 1 out of a 6 total, so the probability of rolling a 1 is 1/6. Part B says, what is the probability of rolling an odd number? So we're going to ask ourselves how many odd numbers are possible. Because remember, a success is any odd number. How many odd numbers do we have? So in this case, we have 1, 2, 3 odd numbers. 3 out of 6 is going to be 1/2. Part C, what is the probability of rolling a number less than 5? So again, we're going to ask ourselves how many numbers do we have that are less than 5? We have 1, 2, 3, 4 numbers that are less than 5, so the probability is 4 out of 6, which is 2/3. And then lastly, what is the probability of rolling a number that is greater than 6? We ask ourselves, how many numbers do we have that are greater than 6? And on a die, how many numbers that are greater than 6? And none. We have no values that are greater than 6. So the probability is going to be 0 out of 6, which is just going to be 0. Let's take a look at some more examples. Here we have a standard deck of cards. The first question says, what is the probability of drawing a 10? So for this, we're going to ask ourselves, how many 10s do we have in a deck of cards divided by the total number of cards? So the probability of drawing a 10, we have 4 10s. We have 1, 2, 3, 4 out of a total of 52 cards. And if you reduce that, that'll be 2 out of 26 or 1 out of 13. So the probability of drawing a 10 is going to be 1 out of 13. The next one says, what is the probability of drawing a heart? So we ask ourselves, how many hearts do we have in this deck of cards divided by the total? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 hearts out of a total of 52. And if you reduce that, that's going to be 1/4. Now, the next one says, what is the probability of drawing a face card? A face card is any card that has a face. So these are all face cards, the jacks, the queens, and the kings. So we ask ourselves, how many face cards do we have? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 face cards out of 52. And if you reduce that, this will be 3 out of 13. Lastly, what is the probability of drawing a black card? So we ask ourselves, how many black cards do we have? We have a total of 13 plus 13. So that's a total of 26 black cards out of 52, which if you reduce it is going to be 1/2. Here we have a roulette wheel, and we want to ask, what is the probability of landing on the number 28? Okay, now first off, let's take a look at how many possibilities we have. We have these 36 numbers, and we have a 0 and a double 0. So the total number of possibilities is going to be 38. Now the question is, out of those 38, how many of them, so we want to know the probability of landing on the number 28. We want to know how many of them are the number 28. There's only one. There's only one number that's 28. So the probability of that is going to be 1 out of 38. The second one says, what is the probability of landing on the first or second column? So we want to know the number of outcomes in the first or second column. So if the little ball on the roulette wheel lands on any number that's in the first or second column, then you win. So we want to know how many outcomes do we have divided by the total number of outcomes. Well, we know the total number is 38. Now let's go and count how many outcomes are in the first or second column. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. There are 24 outcomes in the first or second column, so the probability of winning is 24 out of 38. And if you reduce that, that'll be 12 out of 19. Here's another example. A bag contains 8 red coins, 2 blue coins, and 5 green coins. If you add 8 plus 2 is 10 plus 5 is 15. We have a total of 15 coins. What is the probability of selecting a coin that is not blue? So first let's think to ask ourselves, how many coins are not blue? And we're going to divide this by the total number of coins. Okay, so how many coins are not blue? So we have 2 blues, so we're not going to count those. We have 8 reds and 5 greens. So 8 plus 5, that'll be 13 coins that are not blue. The total number of coins is 15. So the probability is going to be 13 out of 15. The next concept is finding the total number of possible outcomes. So let's say that we have 2 different events. So far we've only drawn one coin, or we drew 1 card. What if we have multiple events? So the total number of outcomes is given by multiplying the number of outcomes for each event. For example, an experiment consists of choosing a card from a 52 card deck and flipping a coin. How many outcomes are possible? So we have 2 different events that are going on. The first event is you choose a card. The second event is you choose a coin. Now, according to this formula, the number of total outcomes is given by multiplying the number of outcomes for each event. So the first event, we have 52 cards. In the second event, we have 2 coins. If you multiply, not 2 coins. A coin has 2 sides, 2 outcomes, a heads and a tail. Cards, there are 52 possibilities. So if you take the number of possibilities for cards times the number of possibilities when you flip a coin, which is heads or tails, 52 times 2 will give you 104 total outcomes. Another example is an experiment consists of rolling an 8-sided die and then rolling a 6-sided die. How many outcomes are possible? Well, so we have an 8-sided die, so there's 8 outcomes. You have a 6-sided die, there's 6 outcomes. If you multiply that together, that gives you a total of 48 outcomes. Now the last concept is odds. Like when you place a bet in Vegas or whatever, you're playing the odds. Not the same thing as probability. So the odds are given as the ratio, as a probability that an event will occur divided by the probability that the event will not occur. So basically, it's a ratio of A to B, where A is a probability of the event occurring and B is a probability of the event not occurring. So for example, a card is drawn from a 52 card deck. Part A says, find the odds in favor of drawing a club. Okay, now odds are written as A to B, where A is a probability of an event occurring and B is a probability of an event not occurring. So here's what we're going to ask ourselves. In favor of drawing a club. So our ratio is going to be the number of cards that are clubs to the number of cards that are not clubs. In a deck of cards, and you can go back to your notes where I gave you guys an illustration of the deck of cards. We ask ourselves, how many clubs do we have? We have 13 clubs. And then we ask ourselves, how many cards that are not clubs? So and I'll go back to that example real quick. So we have 13 cards that are clubs. The other ones, so 13, 26, 39, are not clubs. So the odds in favor of drawing a club are going to be 13 to 39. And here, you're going to leave the answer as unreduced. So leave it as 13 to 39. So this is the number of clubs. 39 is the number of cards that are not clubs. Now find the odds against drawing a face card. Now against a face card, it means that our first event is going to be the number of cards. Now remember, it's against. So number of cards that are not face cards. We want to take the ratio of that to its opposite, which is the number of cards that are face cards. So in this case, because we want to find the odds against drawing a face card. We first want to check how many cards are not face cards, and then we're going to take the ratio of that to the number of cards that are face cards. So let's go back to our deck of cards, and we're going to ask ourselves how many cards are face cards. So we have 4, 8, 12 cards that are face cards. Now we have a total of 52 cards, so if you subtract the 12 face cards, that means 40 of them are not face cards. So the odds are 12 to 40. And again, leave this unreduced. Here's another example. The probability of an event is 26 to 54. What are the odds of the event happening? Okay, so the odds of the event happening is going to be, so remember, odds is that the event happens. So it's a ratio of the event happening to the event not happening. So we're going to ask ourselves, what are the number of possibilities of the event happening? So it's 26. Now here's where you have to be careful. Remember that probability, so 26 out of 54, is the ratio of the event happening divided by the total. And for the second part of the odds, we don't want the total, we want the number of outcomes of the event not happening. So we have total of 54 possibilities, 26 of them is the event happening. So what's left over, which is going to be 28, that's going to be the number of outcomes in the event not happening, right? So the odds for that will be 26 to 28. And then the next one, it says, what are the odds against the event happening? So against the event happening, you just flip it. That'll be 28 to 26. Last example, if the odds for a certain event happening are 11 to 19, what is the probability of the event occurring? Now, probability is going to be the number of successes, which in this case is the event happening, divided by the total. So we know that there are 11 outcomes in the event happening. But to get the total, we're going to add 11 plus 19 because there are 11 ways for the event to happen, 19 ways for the event not to happen. 11 plus 19 is 30. So the probability is going to be 11 out of 30.